Bright Tuty. Every student matters.
Hello students, my name is Sanjay Jain. Today we will start a new chapter called statistics, right? Statistics is an important chapter in terms of, let us say you want to pursue in higher studies the courses like actuarial science. Which course I am talking about? Actuarial science, right? When you complete this course, you become an actuary. And let me tell you, there are very few people who have completed this course in our country, and they are highly valuable people. So statistics, if you continue as field of your study, it will be a great career prospect. Secondly, what is statistics? Statistics is basically collection of data and then interpreting that data to take some decisions. For example, I give you the data of marks in mathematics in your class, right? What I mean is, let us say I write the marks like this: 92, 93, 94, 95, 96. Let us say 92 marks are obtained by 3 students, 93 marks are obtained by 4 students, 94 marks are obtained by 7 students, 95 marks are obtained by 8 students, and 96 marks are obtained by, let us say, 3 students. Okay, if I give you this data, then your school principal or the in charge of your school can interpret this data to see your performance in mathematics. These are marks in mathematics, right? And then can take some corrective measures if he or she thinks like that, right? They may give you an extra class if they think these marks are lesser than what they expected, or they can take some other measures for your class. So this is the importance of statistics, that you first of all collect data, and then based on that data you make some decisions by interpreting that data, right? And to interpret that data, we have to represent that data in certain easy ways so that it is very easy for them to interpret this data. Okay, so let me give you an example. For example, if let us say marks in maths of your class are like this: 55, 58, 65, and these marks are out of 80, let us say. Okay, and one student has got 68 marks, another student has got 69, one student has got 75, 78, and there is a student who has got 38 marks, and there is a student who has got 51 marks. Then there is a student who has got 25 marks, and one student has got 80 out of 80 marks. Okay, now I have written the marks of the students of your class at random. Okay, I asked a student about his marks. He told me 55, so I wrote it here. The next student told me 58, so I wrote it here, and I have written all the marks like this. When I collect data and write it as it is without changing anything in it, this data is known as raw data. Okay, so if I ask you to tell me what is the range of this data, what I mean by range is highest marks obtained minus lowest marks obtained. Okay, so you will start looking for what is the highest marks obtained. Now 80 is the highest marks. Then you will start looking for lowest marks. 25 is the lowest marks obtained, right? So you started looking for highest and lowest marks. Now you can subtract lowest from the highest to obtain the range, which in this case is 55, right? But if I write this data in, let us say, ascending order or descending order, then would it be easier for you to look at the lowest number of marks and highest number of marks? Let us see. Let us write it in ascending order. So 25 first, then I'll write 51, then I'll write 55. After 25 I'll write 38. You would say it is more difficult to write this data than looking for this lowest and highest, but no, you think of this from this perspective, that you need to present this data to your management or to the government, right, for them to take the decisions, or to your school principal in this particular case. So you will not present the data in this raw form and he will keep looking for highest and lowest. So you have to write this data in a certain structure so that it is easier to understand for him. So I am writing it in ascending order. So the lowest is 25, then 38, then I've written it already, and the next one is 51, then I'll write 55, 58, 65, 68, 69, 75, 78, and then 80. So I have written all these numbers here in ascending form. When you write these numbers in ascending or descending form, you could have written it other way around also. Now it is easier for you to see that this is the lowest, this is the highest, and their difference will give me the range of data, going from the lowest to highest, right? This is one thing. Now when you represent data in ascending or descending form, this type of arrangement or this data is known as arrayed data. This you would have studied in data handling chapter in your previous classes. Okay, so this was about raw data and then arrayed data and the range of data, highest minus lowest. Okay, so let me tell you about another term also. Let us say I again write marks, let us say in physics, okay, out of 50, 30. I asked a student about his or her marks and he or she told me that my marks are 30 out of 50. So I am writing it here, 30, then somebody told me 32, 35, 38. Now this student tells me 30 again, then 35, 32, 39, 45, 46, 47, 39, and one student got 50 out of 50 marks. So now I can write this data like this, or the other way of saying this is, let us say if I want to say 30 marks, 30 marks, if I look at these two marks, can I say two students got 30 marks each? Can I make this statement? Yes, because there are two students who told me that they have got 30 marks. And similarly, can I say about 35? 35, the two students have got 35 marks each. Okay, so now let me tell you other way around. Students who obtained 30 marks are 2 in number. Okay, so this 2 is also known as frequency. If I take this data point, that is 30 marks is my data point, let us say. Okay, so if I ask you how many students have got 30 marks, you will say 2 students. How? You counted it from this given data, right? So if I ask you what is the frequency of 30 appearing in this table, or how many times 30 appears in this data, you will say 2. So that is the frequency of 30 marks, right? So this is frequency of data, right? Data and frequency of data is clear to you right now, right? So if I ask you another question, what is the frequency of data point 39, or what is the number of students who have got 39 marks? You will say 1, 2, again 2. Or frequency of 50, you will say 1. So this is about frequency. Now data can be divided into two broad categories: primary data and secondary data, right? Depending on the way it was collected, right? Because data can be collected by you directly, or you can refer to some booklets, newspapers, or some other sources of information to collect the data. When the data is collected by you with a definite purpose in mind, let us say you are collecting the data about heights of the students in your class, and with an objective that you will make a table of this data and present it to your school teacher. Then that data is primary data, that because you are collecting it yourself. Secondary data can be some data. Let us say you are reading a particular newspaper and average scores of some cricketers are given there, right? So you have not calculated those averages, or you have not collected that data yourself. You are referring to that newspaper for that data. So that data will now be secondary data. What is primary data? You collect yourself with definite objective in mind. Secondary data collected through other sources of information. Now, if I ask you which data is more reliable, some of you may jump and say that secondary data is more reliable because it is collected from newspapers and all. No, because you cannot trust a newspaper more than yourself. If you collect some data yourself, that data is more reliable. So primary data is always more reliable. Data in some newspapers, magazines may be biased, or may be collected through some other source, so which may not be reliable. You don't know about that, right? So primary data is always more reliable, which you collect yourself with a definite purpose in your mind. So we have talked about data, we have talked about raw data and then arrayed data, we have talked about frequency, and then primary data and secondary data. So let us, and I've also given you the idea of statistics, that it is primarily collection of data, then representation of data, which you might have studied in data handling earlier also. You might have studied about bar graphs, histograms, right? And then frequency tables, tally marks, etc. So these are the tools to represent the data. And then the most important thing is interpretation of data. So statistics is a branch of mathematics which is concerned about collection of data, let us say through primary sources or secondary sources, then representation of that data. Representation, why? Because it can be interpreted easily. And then interpretation of data, and then you interpret that data through those tables or the graphs, etc. And then you take some decisions based on that data, right? So this is all about statistics, and it is an important branch of mathematics.